All right, so one of the things I forgot to show you was example 3. And I think it's interesting because we talk about domain and range, and many of you freak out when we try to do domain and range. I've harped on you about when in doubt all reals is a really bad policy. Well, sometimes it actually is something that you need. Let's suppose I was looking I had this equation, y equals negative x squared plus 3, and I wanted to find the range. Well, first of all, I want to graph it, and I want to show you how to graph it. So hit the y equals button. You can see that I have a plot turned on at the top. You can see the plot 1 is turned on. So I'm going to go up to the top, hit the enter button, which will unhighlight that plot, and now it is not turned on anymore, but it's turned off. That's just a quick way to turn it off instead of actually going into the scatter plot feature. Now, I'm going to graph negative x squared. Now, for those of you that type the negative, please don't use the minus button. You want to go all the way down here to this negative button. Do not use the minus, use the little negative one. Okay? Otherwise, it won't, it doesn't take kindly to that. So, y equals negative x squared plus 3. You can never graph anything on a graphing calculator unless it's solved for y. That is not always very useful. So we can use other graphing programs like desmos.com/calculator is a great graphing program that we will use in class at different times. So I would like to get a good window for this, but I always want to start with the standard window. So that's zoom number 6. And you know what? I actually got a pretty good looking picture, very similar to what you see in the textbook. So I can see from this picture that it's getting wider and wider and wider and never stops getting wider and wider, either on the left or on the right. That means that the domain is all reals, because it never stops and it will hit every x value. But I see that there is a highest value for y, and then it goes down from there. I never have a y value up here, ever, ever, ever. So whatever that highest value is, that's the maximum for y. So I need to find that maximum. Now there's a couple of different ways to do that. We did that with a graphing calculator, but I want you to hit the trace button. So you may believe right now that you are on the maximum, and that actually may be the case. I think it is in this particular situation. But I remember from Algebra 2 showing you that in order to find the middle of a parabola, we would take the value, the opposite of b divided by 2a. Now remember, in this case, a is negative 1, b is 0, because that's the linear term, and I don't see one there, and c is 3. But it was the opposite of b divided by 2 times a being negative 1 in this case. Now you'll notice that I actually, after I hit the trace button, I typed in the opposite of b over 2a. Now what this is going to do is it's going to take this number, simplify it for me, shove it into this equation, and tell me exactly what the y value is. And it was 3. 3 is the highest value. Now there is another feature you might want to use to double check that. It is the calculate feature right above trace. It says calc. So I'm going to second calc, and then I see one that says maximum, because I know that this is a maximum point. You'll notice this unusual feature on the calculator says give me a left boundary. So if I know that this is close to the top, I'm going to come a little bit to the left, and you'll notice that I used the left arrow to go a little bit to the left, and I'm going to hit the enter button. Now I don't have to use the arrows. If I know that 2 is on the right hand side of this maximum value, then I can just type the number 2 for the right boundary and hit enter. You'll notice that it has put 2 arrows on the graph, and when I hit enter this next very time, I don't want to guess. I can talk to you later about what the guess feature does. I'm going to hit enter, and it is going to find the maximum for me. Now I would like to point out to you something right here. This looks really bizarre. Look at that x value. It is, remember, scientific notation at 10 times e to the negative 7th. This is so close to 0, but the calculator doesn't realize it. So in using the maximum feature, sometimes you get slightly odd values like that. This value is so close to 0 that we assume that it is 0. So sometimes when you calculate things like that and use that whole left bound, right bound, it gives you weird numbers. Look, that time it calculated it, it gave you a completely different number, but it's so close to 0 that I can make that assumption that it is. So anyway, those are a couple more things on the graphing calculator that you can use to help you find domain and range. Oh, by the way, since the maximum is 3, then the range would be anything 3 or below. We usually say y is less than or equal to 3. See ya.